Welcome everyone to the second event of Artificia. Artificia is a brand new platform for promoting and sharing knowledge of augmented creativity and the use of artificial intelligence in arts with all kinds of audiences. From the platform's website, artificia.pro, experts, artists, and researchers can show their projects and promote a debate around the interaction between technology and the arts in the creative process. Artificia is a collaborative project. Research centers like the Artificial Intelligence Research Institute of the Spanish National Research Council, the Music Technology Group at the Pompeu Fabra University, and other educational centers like the Escola Superior de Música de Catalunya have contributed to the studies and information provided by Artificia, along with companies like the Visual Suspects, UPF Ventures, or Creo Musica, as well as music festivals like IIIA. In the second event, we also count on the collaboration of the Auditori de Barcelona. After the first event, held on March 10th, covering the use of artificial intelligence in musical improvisation, we will dedicate the second session to music composition using AI. So, let's begin from the Pompeu Fabra University. Let me introduce our guest moderator, Ramon López de Mántaras. Ramon is Research Professor of the Spanish National Research Council at the Artificial Intelligence Research Institute and pioneer of artificial intelligence in Europe. He is the founder of the Artificial Intelligence Research Institute and recipient of several international awards in AI. An important part of his research has been dedicated to AI and music. Ramon, we are very happy to have you conducting this second event for Artificia. Thank you for your support and generosity. And now, it's all yours.
Thank you very much, Nicole. Welcome everyone to this session. Let me start by giving some historical background, historical context on music composition using AI. The application of AI to music started as early as 1957 with a computer composition entitled Iliac Suite for a string quartet. The composition process was based on a software developed by Hiller and Isaacson at the University of Illinois. The AI software was used to generate notes using a generate and test approach, generate notes in a pseudo-random way by means of a Markov chain procedure. Then these notes, once generated, were tested, applying a set of rules of composition and rules of counterpoint. And only those notes complying with these rules were kept. It is worth mentioning that even today, some AI-based algorithmic compositions follow a similar, although obviously improved, process. Perhaps the main addition in AI-based composition is that today, besides systems with manually provided rules, there are also systems capable of learning patterns based on analyzing human compositions. On the other hand, I often say that human composers are thinkers of sounds. Their stock in trait is auditory imagery. They manipulate tones in their minds as accurately as writers manipulate words. Understanding auditory imagery and its basis in memory is the first step to comprehending how composers work their marbles. The American composer Henry Cowell described auditory imagery at its best. He said, "The most perfect musical instrument in the world is the composer's mind. Every conceivable tone quality and beauty of nuance, every harmony and disharmony, or any number of simultaneous melodies can be heard at will by the trained composers. Composers can hear not only the sound of any instrument, but also an almost infinite number of sounds, and many of them cannot yet be produced on any physical instrument. Cowell refers obviously to analogic instruments, although it is true nowadays that contemporary music has extended the space of sounds by digital means. On the other hand, when asked about his approach to composition, the great jazz piano player Herbie Hancock, in an interview, said, "I usually start thinking about the bass line, the bass. Then I try to figure out where it gets boring. Should there be rhythmic changes? Should there be changes in chord density, in harmony? Where should there be the melody? Should it be placed strictly or in a skeletal way so that the person who will be playing it will have more freedom to create his own part? How far should I go?" That's always the big question, he says. From what I have said, we can immediately realize that an artificial intelligence, no matter how sophisticated, will never be a thinker of sounds in the sense of Henry Cowell. Neither will ask itself questions such as those of Herbie Hancock. Let me say it clearly, whatever an AI-based composition system does has nothing to do with what a human composer does. AI is a tool that does not need to be really brain mimetic. Being a tool, you cannot pretend to be brain mimetic. I mean, it doesn't need to be in order to be useful as an enhancer of human composition, which I think we'll see later, probably, and then in the debate. I think it's a key aspect of AI-based composition, being enhancers or amplifiers of the human creativity, human composition in this case. This is not only true for music composition. Actually, this is true for the whole AI. The way an AI reasons and learns might be more or less inspired by how we humans do it, but it is radically different. Technology in general achieves its goals by means different to those of nature. A clear example is that airplanes fly by means other than propelling themselves, flapping their wings. AI-based music composition systems propel, in quotes, themselves without thinking about sounds. And I think this is a big difference between human and computer-based composition. Let me now introduce the participants of today's session. Hi, hello everyone.
Hi.
We have today with us, we have the privilege of having with us a group of people which are very well known in the fields of AI and music, composers and technology. Let me briefly introduce all of you, each one of you. Let me start by Dr. Marco Schorlemmer. Marco is a tenured scientist at the Artificial Intelligence Research Institute of the Spanish National Research Council and is head of the Multiagent Systems department. He also is the co-editor of the book Computational Creativity Research Towards Creative Machines and Concept Invention. Dr. Schorlemmer has recently coordinated the European Union project CoInvent on computational creativity, and what he is going to explain today is related to some results of this European project. We also have with us today Emilios Kambropoulos. Emilios is a professor of musical informatics at the School of Music Studies in Aristotle University of Thessaloniki. His research interests focus on cognitive musicology, artificial intelligence and music, computational models of musical structure, expression and creativity, and he is the director of the Cognitive and Computational Musicology group. Next, we have Danae Stefanou. She is an associate professor at the School of Musical Studies at the Aristotle University of Thessaloniki. She teaches experimental music, critical studies, and contemporary music history. She is founder and director of the AUTH, Experimental and Improvised Music Ensembles, and 2 study groups on arts-based research, and also a critical historiography, critical music histories. She is also founder and co-director of the CYROS, Sound Meetings, an initiative for experimental site-specific sound and intermedia project in CYROS in Greece. Next, we have Artemi Maria Giotti. She's a composer and researcher working across the disciplinary boundaries between art, science, and technology. Her research interests include computational intelligence, musical robotics, sonification, as well as collaborative and participatory sound art. Her compositions include works for solo instruments, ensemble, live and interactive electronics, and have been performed in Greece, Austria, Portugal, Germany, Denmark, etc. She is the principal investigator of the artistic research project Interagency, hosted at the Institute of Electronic Music and Acoustics in Graz, in Austria, and where it's exploring the potential of artificial intelligence and machine learning for electro-instrumental composition. Then we have, more locally, people from Barcelona, Ferran Cruixent. Ferran Cruixent is one of the most performed Catalan contemporary composers worldwide. His repertoire includes commissioned works for orchestras, chamber music, dance, and visual arts, and his symphonic works have been internationally performed by over 40 different orchestras. Ferran studies the intersection between body and technology in the new technological society, looking for a way to incorporate this relationship into the artistic musical universe in different forms. Then we have also Artur Garcia Saez. Artur is a physicist and engineer and works at the Barcelona Supercomputing Center. His research is focused on quantum algorithms and machine learning. He has collaborated in different projects investigating the relationship between art and science, and he is currently part of the team that is developing the BSC, Barcelona Supercomputing Center, first quantum computer, and has collaborated with Ferran Cruixent, as we will witness, as we will see also today. All right, so these are the participants of today, and what we're going to do now is we are going to give the floor first to Marco Schorlemmer. I think we have first some stinger, right? All right. So, Marco, the floor is yours. Thank you.
Thank you, Ramon. Well, creativity often lies in the novel combination of familiar ideas. It doesn't matter if it's prehistoric art, such as the ivory sculpture known as the Lion Man, which combines traits of a lion with that of a human, or if it's abstract mathematics. In cognitive science, this principle has been called conceptual blending, and some years ago in the European project Co-Invent, we developed a mathematical and computational model of this cognitive principle. One of the domains of application in which we explored our model was music composition, and in particular, the task of harmonization. We asked ourselves, what could novel ways of harmonizing melodies be that draw from the combinations of different musical styles and idioms? The team at the Aristotle University of Thessaloniki developed a harmonization assistant based on conceptual blending that suggests new harmonic spaces for a composer to explore. And Danae Stefano will now give more details on this.
So no art is produced completely from scratch, and musical composition is no exception. Composing is just about original ideas and new output, as it is about having access to a variety of different materials. And also it's a time-consuming process of taking different elements in and playing around with all kinds of data and improvising with different combinations of that data to create structures, and then also filtering out unnecessary elements before shaping the rest into a new and coherent whole. In music, this process has historically yielded a large variety of new harmonies and new styles. Most of the styles that are now considered classical were the result of a few composers having access to elements from different cultures or historical periods and having the time to play around with them until they came up with their own new compositional vocabulary. But nowadays, more and more composers come to see creativity not so much as a protean act, but more as a result of serendipity, combination, and collaboration. Given the vast and increasingly complex amount of data available, it may also be a little tougher for any singular composer to come up with novel harmonic ideas on their own. Emilios Kamperopoulos will now explain how assisted harmonization can help in this domain.
In the context of the coin event project that Marco just mentioned, Chameleon was developed. Chameleon is an AI melodic harmonization assistant that learns harmonies from data and then combines given melodies with different harmonies or with novel blends between different harmonic idioms. Just to give a small idea of how this blending works, a chord transition can be described as consisting of two chords plus various relations between the notes of the two chords, what's called voice leading. Let's suppose we blend a classical tonal perfect cadence that has a characteristic upward leading note, for those of you that know a little bit about music theory, with the older medieval Renaissance modal cadence, the Phrygian cadence, that has a characteristic downward leading note. The best blend that our coin event blender can come up with is a chord transition that has both an upward and a downward leading note. And this new invented transition is a transition that appears commonly in jazz harmony and is referred to as the tritone substitution progression. So two supposedly old concepts are blended, giving rise to a new concept, tritone substitution, that did not appear in any of the two initial harmonic spaces. Now, this idea of chord transition blending is extended in Chameleon to the transitions of entire harmonic idioms, giving thus rise to novel, often unexpected harmonic spaces. Young composers at the School of Music Studies in Thessaloniki were invited to create new contemporary compositions collaborating with Chameleon, at this stage with a rather primitive online version of it. Now we will listen to a composition by Dimitris Maronidis for piano. The composer created a set of 7 variations on a traditional Greek folk melody. The composer indicates at the beginning of each variation the Chameleon harmonization he used. You will see some letters on the score. For example, PL stands for Palestrina, and BC stands for Bach chorales. FB, not for Facebook, but Faux-Bourdon, which is a medieval type of polyphonic music. JA for jazz, and things like that, and various blends between such harmonic idioms. Let's listen now to Dimitris and his composition.
The way I took advantage of using Chameleon was by assigning this role to the computer of providing to me an initial data set of musical material that I then used to shape a piece for solo piano. For a composer, this initial stage, when you are in front of an empty page, can be a very difficult one. So asking from a computer to generate this material that you will then use to build your own piece can be a very challenging but a very interesting one as well.
And now we will witness the world premiere of a piece composed by Xenia Constantinidou with harmonizations created by Chameleon based on blends of harmonic styles such as, for instance, that of Bach chorales with medieval organum or that of jazz with traditional polyphonic singing from Epirus. We will first listen to the composer's impression of the composition process with Chameleon, followed by the performance of the piece by the Gradiva String Quartet of musicians from the Barcelona Symphony Orchestra.
Creating a musical work using Chameleon has been an intriguing experience. The system assisted me in the compositional process by providing a variety of harmonizations in different styles and blends between harmonic styles. Some harmonizations were awkward, some unexpected, some commonplace, some exciting. I played around with the system, trying out different harmonizations on traditional Greek melody. As I wanted to make most of the Chameleon assistant, I decided to compose a piece in the form of theme and variations. So I used blended harmonic styles generated by Chameleon, except the theme and last variation. I then configured the character of each variation according to my own compositional preferences. The resulted quartet was created both by me and the Chameleon assistant. Overall, this interactive composition experience was interesting and had moments of awkwardness as well as moments of excitement.
Good. Thank you very much, Marco, Danae, and Emilios. I have a short question, but before, let me remind everyone in the audience that you may ask questions through the chat. Okay, so don't hesitate to ask questions. Now I have a little question, as I said. Maybe to Danae, because Danae, I think you mentioned something about serendipity. And I wonder if serendipity is something that is more likely to occur as a result of the collaboration between, let's say, a human composer and an AI system, or maybe among different humans too. So do you think that serendipity is very much related to the fact that you are cooperating, collaborating?
Absolutely. Serendipity can only really occur when you open yourself up to something unknown, right? As composers, sometimes, and generally as musicians, we tend to have learned behaviors. So sometimes we think we might be spontaneous, but really we're drawing on a slightly narrow, perhaps, cultural background. It may be very big in our minds, but we can only figure out if something random is going to happen if we open ourselves up to something unknown. In this case, the collaboration opens up this possibility. We might think of a harmonic space as new, but it might not be as new as if it's going to come from an outdoor source.
And do you think that when, let's say, the agent you are collaborating with is let's say, an AI system, it will increase the likeliness of serendipity compared to collaborating with a human, or because maybe the AI system had some sort of more, let's say, exhaustive search of the potential of the space of possible combinations, and that may make you discover by serendipity something that you didn't think of, and it might be very interesting. What is your opinion about that? Anyone? Yes?
I don't know. I mean, if I'm to offer a quick opinion on this, it would just be that because the system, especially if it's relatively new, it can also come up with certain wrong, let's say, answers. You know, it can come up with certain things that you wouldn't normally do as a composer because you haven't been trained to think like that. It allows for options that you wouldn't normally consider. So I think that's an area in which serendipity is slightly different when you can compare, you know, AI agents with human agents. But of course, in this case, we're talking about harmonization, which in itself is a kind of gridded system in a way, right? I guess in other examples, when we deal with improvising agents, then obviously serendipity is a whole new terrain. And, you know, we're going to hear more about that in different sessions.
The previous session, we was the subject was about improvisation. Yeah. Okay, well, thank you very much. Later on, as you know, there will be an open debate, and we'll have the chance to discuss further on this issue, Iron Chameleon and concept blending, which also there are some questions maybe about concept blending later on. Okay, so thank you very much, and see you later at the open debate, of course. Thank you.
Thank you.
Thank you.
Okay, welcome, Artemi Maria Giotti. As I said earlier, she's a composer and researcher, and she's the director of interagency project hosted at the Institute of Electronic Music and Acoustics in Graz, in Austria. She will, I think you will present us Bias as a project, right? So the floor is yours. Thank you for being here.
Thank you for the invitation. So today I'm going to talk about Bias, which is a recent work of mine for bass clarinet and interactive music system. So in this piece, the interactive music system listens to the musician and evaluates the sound material that he plays aesthetically. So the computer music system is equipped with aesthetic preferences. That's the main idea in the piece. During the performance, the computer will respond to sounds it finds interesting, but will remain silent or propose new sound material when it loses interest in the musician's input. The starting point for this piece was a series of machine learning experiments in which I attempted to train neural networks to simulate my own aesthetic preferences. So with the help of clarinetist Szilárd Benez, I recorded some improvisation sessions. I then segmented these recordings into shorter musical excerpts and evaluated those excerpts based on my subjective aesthetic preferences. So, for example, I evaluated these excerpts on a scale from 1 to 5, where 1 corresponded to not at all interesting and 5 corresponded to extremely interesting. And then, of course, I used that data as training examples for the neural networks. However, the goal of this process was not to train the neural networks to simulate my own preferences as accurately as possible. So the title of the piece, Bias, actually partly refers to the phenomenon of AI bias, which is recently gaining more attention, and it consists in machine learning algorithms making arbitrary assumptions about data or false assumptions about data, essentially developing a form of bias. So what I was interested in and what I wanted to see through these experiments were the different ways in which the neural networks would misinterpret my aesthetic preferences and deviate from them. I was interested in the mistakes that the algorithm would make. So the end product of this training process is not an AI that 100% reflects my own aesthetic preferences, but an AI that creatively misinterprets them and essentially takes on a life of its own. Another interesting aspect of the piece is that I have not composed any of the electronic sounds that are heard in the performance. So the computer music system simply records sounds it finds interesting in its interactions with the musicians. And this is another way in which the system is almost autonomous of my own agency as a composer. I think there is a video of the piece that we're going to play next. And just as a piece of advice, it turns out that the computer music system really likes low frequencies, so it's best to listen to the video with headphones on.
Thanks very much. Now we have a question from the audience, but before, I think the question is already there, but let me also ask myself a question or a comment. You mentioned that the system imitates sounds it finds interesting, right? Now, I'm curious to see what is the concept of interestingness in an AI system, right, on your system, because when it comes to humans, it is rather well known. There is quite a lot of work has been done already. For example, the paper "Music, Mind, and Meaning" by Marvin Minsky, that says that there is a trade-off between being able to anticipate too much what is going to happen next and not being able to anticipate at all. No? So in the first case is when we get bored and we think that the music is not interesting. And in the second case, you cannot anticipate basically almost nothing, right? We feel that music doesn't make any sense and we dislike it. So although there is lots of studies about what humans, how humans react to this type of, to these aspects, right? I'm curious to see if you can tell us something more details about the concept of interestingness in your systems and who has decided. I guess that is not, obviously it's not the system by itself who makes this decision autonomously. Or can you tell us?
Yes, actually, in a funny way, it is the system that decides that. So the piece poses the question what is interesting rather than answers it. So it's a comment on aesthetic judgments as inherently subjective and subject to change. So as I mentioned in my introduction, what I did is essentially I just recorded a lot of sounds and I evaluated based on my subjective preferences. So I preferred certain sounds more than others. Though if we want to talk in technical terms, I have to admit that my intra-rater reliability was awful. So listening to similar sounds for a long time, you start to evaluate them differently. So that's another aspect that I find very interesting about this experiment. What is interesting if you don't have any context? So, but I let all these aspects, all these parameters influence the data collection process and the training of the neural network. And what I wanted to see was how the neural network is going to make sense from my own evaluations. And as I said, the point was not to train the neural network to 100% predict how I would evaluate a new sound. What I wanted to see is how the neural network will misinterpret it. So my aesthetic preferences are the starting point for the machine learning algorithms to develop their own bias, and so to become a sort of independent agency. And so what happened in these experiments is that the neural networks captured my aesthetic preferences to some extent, but also weren't able to capture some of the subtle differences. So the neural networks really like low frequencies, as we heard in the performance, and they like drone-like, slowly evolving sounds. I think these are all not far from the truth. So I do like low frequency sounds and slowly evolving sounds, but I think that the neural networks took that really to the extreme. But I actually used that and exploited that compositionally. So I thought, why not use that and really create a piece that is based on very slowly evolving sounds? So that's an interesting way in which sort of the creative interpretations of my aesthetic preferences by the neural network fed back into the compositional process and influenced the piece.
Let's recover the question from the audience, please. I think, here it is. Does the model have a sentiment classification?
No, it does not. No,
doesn't.
It just performs this regression task where it is just evaluating incoming sounds and texture. So it doesn't just look at the sound event level, but also at larger windows of 5 seconds, for example, and then 20 seconds and so on. And it's just about aesthetic preferences. It's just about, is what I'm listening to right now interesting or not? That's it.
Very good. Thanks very much. And later on, of course, it will be also part of in the debate, in the open debate. Thanks, Artemi. Thanks very much.
Thank you.
All right, so now we have with us again Ferran and Artur. As I said, Ferran is a very well-known Catalan contemporary composer, well-known worldwide. And Artur is a physicist and engineer that works at the Barcelona Supercomputing Center. And I have been both collaborating, right? And Ferran and Artur, they are going to present us their work, and particularly the Human Brother, I think Human Brother project, right? So, Ferran, the floor is yours. Thanks for your participation, for being here today. Thank you.
Thank you. So, well, first of all, I will introduce my life. For most of my life, I've been fascinated by music and science, acoustics, physics, nature, human psychology, and above all, the love of observing the world around me. The way people relate to technology is changing incredibly in recent years. It's disturbing because it seems like the brain can't digest so many changes at once. But it's also fascinating because it allows us to play and imagine new worlds like never before. Virtual reality is an example. What we call artificial intelligence is one more step in all this frantic and at the same time magical path. This technology has begun to mimic what people do, such as recognizing letters, the position of faces, expressions, the content of photographs, or recognizing music. In fact, it's already generating very characteristic creations of its own and creating relationships that sometimes would not occur to people to be absurd or impossible. As in its day, the creation of the pixel changed the visual aesthetic, years ago, I began to imitate with musical instruments sounds of the soundscape and also sounds from the technological world, incorporating them into my harmonic imaginary. 2009, I received a commission by the Staatstheater Weimar, and I decided to write a work called Cyborg. During the composition process, I started asking myself how to mix technology and music, how to involve the musicians themselves as cyborgs in a traditional organization like a symphonic orchestra. I found a solution that I called cyber singing, a musical technique where musicians become cyborgs because they use their own phones playing motifs composed by me while they are still playing with their own technology, their own traditional instruments. Let's watch a short video about this.
The first piece on our program is, for most of you, unlike anything you have ever heard. It's called Cyborg, a cyborg being a part human and part mechanical organism. To that end, the orchestra in this piece assumes both roles, and most of the sounds that you hear, which seem to be mechanical or unusual, are produced by the musicians without any aid of electronic devices. The composer, who's a big fan of science fiction, decided to try to create a piece that combines this world of music with the world of fantasy. You don't listen to this piece necessarily for its glowing tunes, although there are many in it. You listen for the sonorities, the power of the loud music and the delicateness of the soft music. But you also think about it in terms of the relationship of people and machines. How does an orchestra, instruments, people here who are playing on instruments that are 200 or 300 years old, how does that relate in the 21st century? Well, for this piece, the orchestra does take on the role of cyborgs because near the end, each of them has a pre-programmed ringtone in their phone, an MP3, which they will then turn on, creating this little galaxy of stars on music and items that are based within the whole piece. It's a fantastic world here, and the 20 or so minutes it takes brings you to something brand new. So listen to it in a very open way. We've fallen in love with this. This is just a terrific, wonderful new piece.
So after this work, I got more commissions, and thus I could write a whole tetralogy of the cyborg. So 2010, Cyborg was played in Weimar, then in Detroit 2013, and 2011, a new commission, Virtual, with the Deutsche Radio Philharmonie, Saarbrücken, Kaiserslautern. Then came 2016, Big Data, with the Detroit Symphony Orchestra, and 2018 Deus Ex Machina in Barcelona with the OBC. After the world premiere of Deus Ex Machina, the same orchestra, OBC, proposed me a new commission to open the symphonic season 2019-20 in Barcelona. I brought a work for soprano and orchestra, and I decided to go one step further, exploring the relationship between composer and artificial intelligence. I wanted to contrast the depth and breadth of human intelligence with AI, because for me, AI, it's not yet intelligence. It is machine learning. Human intelligence is, to me, something more wonderful than a set of algorithms. So I got in touch with the doctor in physics, Artur García Sáez, from Barcelona Supercomputing Center, and he was totally fascinated with the idea. My goal was to let the supercomputer Mare Nostrum 4 compose new music after processing all these audio files. Artur loaded recordings of my whole tetralogy, Cyborg tetralogy, and let the machine learning process do something with it. The results were awful. So the machine couldn't definitely compose as if I were, but the error, the stacking rhythmic, was pure inspiration to me. In a way, I have ended up writing music as if I were the machine, imitating its error, its characteristic, and I have incorporated this into the work. Human Brother starts with the original audio results played through the musician's smartphones, as we have seen in the previous video, and after that, the whole orchestra starts, so you get the feeling that the orchestra takes over the sound of the computer and opens it up to the real world of sound. Artur García Sáez also loaded melodic audio files like Gregorian chants and also ancient Greek melodies. The results after processing them were really surprising, because after Gregorian chants, for example, the supercomputer gave us a kind of melismatic Arabic motifs, a piece of irony that we can hear at the very beginning of the piece. I brought by ear all the identifiable melodies to use them during the compositional process. After all this research, I wrote a poem called Prayer for the Human Brother, and then I composed it without any more aid of artificial intelligence. In Human Brother, the AI was used as a kind of inspiration, and therefore my approach was more philosophical than finding specific algorithmic results. From a whole duration of almost 30 minutes, we will hear only about 5 minutes of audio excerpts, and you will also be able to read the lyrics. The soprano plays the role of an artificial superintelligence of the future who comes to give us some messages that I myself dreamed of. Human Brother is an ode to quantum physics, to the energy that has existed since time immemorial and of which religions already speak. It's nice to see how physics becomes philosophy in this 21st century. Basically, it's about having faith. While you believe, the possibilities are endless. When you observe and control, everything collapses into a single reality. After the following video, Arthur will introduce us to some details about the machine learning process used to create the sounds. Thank you very much.
Within me there is no intelligence, only artifice.
So I can give you my recount of this project with Ferran, which was, like he was mentioning, very, very fascinating, I would say, from the technological point of view of a physicist or a computer scientist doing music. I'm not a musician. I'm a scientist. So the thing was like a very challenging project, also from the point of view of the technology that we use to synthesize all these raw audio, and actually our approach was, or at least in my case, I was very curious about which were the possibilities of today's technology to synthesize music in the more like a general sense. So the idea we were using here is to process music from its pure format, like audio music or audio files, which for which we don't have any knowledge about the content or the music. So actually we were using machine learning techniques which have been developed for human voice synthesis for reading text, for instance. So it was kind of a challenge to check all these possibilities in terms of what powerful machines, as the ones that we have at the Supercomputing Center, can do with powerful algorithms as the one that we have developed in the last years. By we, I mean the machine learning community. And actually, it was very interesting because some years ago, we took part in some similar project based on MIDI files. So we were processing like text files representing music. And in a few years, we could see that all this technology, both in algorithms and also hardware, could evolve to the point of processing raw audio, which means like thousands of points per second, describing the wave function of sound. And the main conclusion that I got from this project was that music is very hard. It's much harder than processing images or processing only a single voice. And actually, there were different degrees of hardness in this problem. And I would say probably Ferran's music qualified as the most difficult music to synthesize. And that's why we were trying like many different data sets that we were like mixing and combining different types of music. And probably not surprisingly, because of these techniques were developed for human voice, the best results were obtained for choral music, for human cores. So we were using that, and actually I was kind of, let's say, surprised because we finally got some results that were considered to be good, or I mean, it's very difficult to say good or bad because we are talking about artistic creation, and that's another interesting point of this. The application of all these techniques to this problem, because normally we deal in machine learning with like numerical evaluations of the outcome. So we know if we put a correct label on an image, or we synthesize something that has some meaning because it's a text that has a proper like right construction. But in artistic creation, that's very wavy. I mean, it's very difficult to say if something is good or bad or wrong. So that was something that for sure we need like an artist in order to make sense of all the outcomes of all these algorithms. So I'd like to finish just to mention that actually this was like a small project that we developed with Ferran, and it was very exciting, and we decided to move forward and follow doing these kind of projects and interactions. And actually there is an ongoing collaboration in order to bring all these tools that we develop inside the BSC to a broader audience of artists that they can use in their own compositions and deal with the models, which are normally complex for a non-specialist to use. And this is an ongoing collaboration in the scope of a project, of a European project that we got funded, which is called AI for Media, and which will hopefully deliver all this technology into a closed platform in order to create music from data sets of audio.
Okay. Yes, thanks, Ferran. Thanks, Artur. There are some comments and some questions from the audience, I think. But in the meantime, let me say something. I think, Ferran, you mentioned, if I understood well, that at some point that errors by the system or by the machine were an inspiration. Is that what you said?
Yes.
Yeah?
When I heard for the first time, so Arthur put all this cyborg tetralogy in the machine. So he took small samples and put this in the machine and let the machine learning do the process. And then I heard the first results, kind of 15 seconds of music. And he tried to do something new, and then he stuck. So it stuck in a repetitional way, rhythmic, and so a kind of beginning of something big, and then and I was fascinated by this rhythmic. At the beginning I said the machine learning, the artificial intelligence, it's bringing us some characteristic creations of its own. It's maybe it's absurd, but for me this absurdity was at the same time inspiration. So that's why the piece, it begins also with this rhythmic. The whole orchestra is playing this stacking rhythmic. It's very fascinating to me to make this step forward.
Yeah, maybe we could say that you also experienced some sort of serendipity, like it was mentioned before, right? You said all the time, well,
yes.
that I can exploit that, or I can take advantage of what's happening, and gave
yes.
you what you call inspiration, right? So
yes, and I gave some sense.
Okay. And Artur, do you think that this initial experiment with giving all this strange or error output was because the training data, the training set was not good enough, not large enough? Because your data set was wave functions. I mean, what was sound?
Yeah, we were using no codification of music at all. So there was no like score or like sheet music or anything like that. It was just like pure audio music. So the source of error, I mean, we have algorithms that are intended to bring some dependent. I mean, this is a time series, and music has like different scales, right? I mean, you have like one sound after the next one in a millisecond, but then you have like large scale structures. So representing all these different scales or structures is very difficult.
You have this hierarchy, right? Hierarchy of motifs, phrases, and okay.
Exactly, and we are using actually a neural network in order to represent this hierarchy, which also has this shape, right, of a kind of a tree. But the power of training this tree, I mean, it's very difficult. How to fit all these sounds into this tree, and actually the problem may not have solution. So I mean, what's the point of training music from human voice with violin or whatever instrument? So I think that these should be defined in a more precise way, instead of putting everything inside this data set and hopefully just getting something good.
I think it was really difficult because the orchestral music is so complex that the machine couldn't start with. And with the melodic melodies, like ancient Greek melodies and also the Gregorian chants, it was the opposite. So we became kind of Arabic sounds, but also the text was completely disordered. So I could write by ear all this information and also the text. And it was really, really fascinating to me to start. The soprano starts with this new language, future language. So a kind of metaphor all the time.
Well, that sounds very interesting. Yeah, I mean, because I was wondering also, how do you make you need an error to propagate, to back propagate, right, Artur? So how can you assess the amount of error that you propagate? Can you tell us a bit more about that?
I mean, this is a training process. So we use like a bunch of small audio pieces that this neural network has to mimic. And so basically you expect that the neural network will guess what's the new sound and compare with the real piece of audio in the data set. But that needs thousands of predictions per second, because we are processing audio in high quality. So that means that the sources of error can be, like, as I was mentioning, like in different scales. You may miss the next millisecond or the next second completely. And so all these errors combine, and actually training all these models was somehow difficult, and trying to reduce the error was complex. But yeah, it's like a supervised training.
And the fine thing is that we put audio data. That means there are recordings played by humans, and the computer is playing with this, and we get an output of human recording modified. So it's metaphorical. Very interesting.
Very good, very good. Okay, now just a comment that has been by the audience. There's a comment by Dimitra. She says that a very interesting concept of cyber singing, trying to sound digital with analog instruments. You have it in the screen, in the screen now.
Okay, thank you.
Yeah?
Yes, that was my goal in my piece. I tried to imitate sounds, to put sometimes to play with old technology like modem, like Morse code, for example, and to put some messages in Morse code with instruments playing, for example, big data, or I like to play with all this or imitate modem fax. We will hear it at the end of the session with the last piece.
It was a surprise, but you already mentioned it. Okay, no problem. Okay, now I will like to invite all the other participants, because we are going now to the open debate. Yeah, what we call the open debate. Obviously, any of you may ask questions to other participants among yourselves, and I don't know if there are questions from the audience too, but if there are, we will see them too somehow written on the screen. But anyone, I invite any of you to ask questions to each other if you think that you have some questions, some burning questions or something. If not, there is something here. Are there any papers about this subject that you can recommend? On which subject? We don't know, right? Actually,
I think this is for me. I think the question is for me.
For Maria, for Artemi Maria, yeah?
Yes.
Okay, yes.
So actually, there is a paper coming up. It's not published yet, but it will be published as part of the proceedings of the International Conference on New Interfaces for Musical Expression very soon. And the paper contains some technical information about the neural networks, but also information about the compositional process, my collaboration with clarinetist, and the more theoretical background behind the work.
There is something else here about very interesting, the impossibility to define interesting as a constant function, because with the events, could we write down all values and extrapolate that function? So that may be, who is Danae maybe, or the chameleon team might take this question, perhaps.
I think I have a feeling it might be more related to Artemi, but I could hazard an answer. But
Artemi.
So yes, if this is for me, I guess that could be interesting to extrapolate that function. It wouldn't be a linear function for sure, but yeah, it's an interesting question. Yeah, I haven't thought of it.
Yeah, now I myself have a question to the Chameleon project, to the team. Maybe Marco, could you elaborate a bit more about this idea of concept blending, this technique about concept blending, maybe in a couple of minutes. Marco, please.
Yes, it is. This is a theory that comes from cognitive linguistics, and it is based on the idea that we often combine concepts by discovering or by finding structural similarities of two different concepts, and then identifying these similarities and then blending together the things that are dissimilar. And this can happen very obviously, for example, if we think of the mythological figure like the Minotaur, which is just a blend of a bull and a person. But it also happens with very mundane things like my morning coffee, which is a concept that blends all the coffees that I take every morning. It's not a particular coffee that I drink, but it's this coffee that I drink every morning that has structural similarities and also differences. And all together blended in one concept, which is the idea of the morning coffee. Now, this is what has been a little bit, can be explored in many domains, obviously, and which in Chameleon has been explored to blend, to make chord blending, to make cadences blending, to make these, and then to extend it to these blending of harmonic spaces.
Anyone else from Chameleon?
Yeah, I could just.
Yeah, Emilios.
Yeah, just to add on that, for example, we can blend tonal music, tonal harmony, in two different keys. So it's just plain tonal Bach chorale, let's say, harmony. And one is in C and the other is in E major. Blending the two creates a totally new space, which can be very chromatic. It can be way beyond the two things we started with. And I think that's one of the powerful things with this concept of blending, that something is created which has characteristics from two different spaces, but then it has a life of its own. It has a character of its own, which goes beyond the two spaces it started with. And that's part of creativity, how we combine different ideas, get new ideas also in music, create new music.
Because the main focus was blending chords, right? That was the Emilios, or the key, the core of Chameleon in this music application was chords blending.
Yeah,
or more than that.
The main blending is chord transitions. Not just single chords, chord transitions.
Yeah. Sure.
But when you blend chord transitions from the same space in a different key, then you get very strange transitions, which create a whole new chromatic space. And this is what we've been trying to explore. It's when it's different spaces, it can be jazz with medieval music, then it's really very weird. Sometimes it can be awkward, sometimes it can be, you can think it's really bad, but then, an open mind can find interesting things and create something new. So
that could be something like different styles, musical styles, blending different musical styles, or harmonizing in a style according to the chord progressions of another style, or something like this.
Yeah, well, the idea of, for example, having a melody and having different style harmonizations, we've tried, take a melody and have lots of different, that's blending different styles. But trying to blend harmonies, that was a bit more strange, curious what would come out of that. And there are some interesting things. Okay, everything is up to now in a proof of concept kind of stage, trying to figure out what exactly is happening. But I think it has, it's not just throwing things together and just mixing up. it's a little bit more sophisticated, but trying to combine in a way which is meaningful according to the convent concept.
I think there is now a question from the audience for Artemi. Is there an aesthetics of coding? How much does the methodology developing the AI have its own aesthetic influence on the work? It's for Artemi, I think, the question.
I think so, yeah. So
yes.
I'm not sure to what extent programming languages like SuperCollider might have an influence on the work, but definitely the AI had an influence on the work. So as I said before, I realized that the neural networks were in fact learning some interesting correlations between the data in my own evaluations, my own aesthetic preferences, but they also deviated from them and took them to the extremes. So I also decided to take this piece to the extremes and really explore these spaces that the algorithm seemed to like. So this is something that I don't think that I would have gone there if it weren't for the neural networks just preferring these kinds of sounds.
Thank you. I have myself, it might be possibly the last question because of time. It's a more general question. It's for Ferran, perhaps. Yeah, Ferran, please. It's more general question about the role of AI-based composition. It's something that many people say. I think it's true. I find myself with this question myself several times. In that the audience, when you play like your work, right? That has been played in different orchestras around the world. So often the audience never clearly knows how much of what they listen to can be credited to the AI and how much to the human composer effort. So what elements, what notes, motifs, harmonies, rhythms, timbres, what elements are generated by the AI and what elements are not? What is the this symbiosis of collaborating man and machine or human and machine is often not so clear. What is your general thought about that?
Yes. So if we analyze, for example, compositions based on cliches, such as film music, maybe an AI will be soon able to replace many of the compositions you are hearing now on TV or maybe. But if we talk about the need to say something, you need to express, to talk about yourself. AI will have it much more complicated. So it can help to give you a cue, or it can be a game, like a game with like in Human Brother. It was an approach in which I have played with the possibilities offered by the technology, but I like to maintain the independence of following my own inspiration and intuition. Maybe in the future, a machine will be able to learn from myself and offer me options, but in each new work, I look for new paths, so that I have never explored, maybe. And therefore, I find it difficult to think that AI will help me in this process. Because for the machine, it will be difficult to predict what I will write in 2 years from now. But otherwise, now an AI can offer me a lot of combinations. So I think there will come a time when an AI will know more about myself than I do. So when this happens, I will naturally transfer authority to the machine. the machine
And
will
then you will not be needed, or what?
I don't know. I don't know. The machine will be our artificial mentor. So, is it really what we want? So, I guess we can't choose anymore. But the most important thing is to be aware of it. So, maybe if the machine knows us psychologically, can it help us not to lose creativity with unnecessary worries? Maybe the machine can help me and tell me, okay, you are in the good way, you are in the wrong way, your intuition is okay. Yes, you mentioned about the audience. It could be a nice game, a nice play to start writing some music with and without artificial intelligence, and then without saying anything, and then asking the audience who was the real composer and who was the artificial.
A Turing test, right? A Turing test for music.
Yes, for example. but I think dramaturgy is really very difficult. So in the field of composition, we have seen melody assistants, like in Google Arts, harmonizers, algorithms that can imitate composers in a rudimentary way, like Deep Bach, or others that take advantage of huge libraries of a dead artist to create new songs, as in the case of deepfake Sinatra. Some are based on MIDI information, others work directly with audio files, but we have yet to see if an algorithm will be able to create credible dramaturgy. So rather than vomiting amounts of notes following pre-programmed rules. So a composition made with AI maybe surprises us at first, but after a few seconds we perceive it as empty music without soul, intuition, or inspiration. That is what we should invest in, a kind of holistic artificial intelligence that also covers psychological aspects necessary to understand how an architecture, a story, a dramaturgy works.
So I am right if I deduce that your future plans, at least in the short, medium term, is to keep using AI as a source of system or inspiration or whatever for run?
Yes,
this is your plan? Yeah.
Yes, or dialoguing like in the case of Artemis. So it's really interesting. We don't know what's gonna happen. So
very good. Okay, last opportunity for any one of you or the people who are debating to ask or say something or to add some comment.
Well, just go ahead. Sorry.
Yeah,
no,
sure.
It's fine. Just a question for Artemi, a very small one, because I found the idea also behind your work fascinating, and I'm wondering about the sense of time, temporality in bias. If you had any observations also from the performers, about maybe how long it takes between phrases and how the interaction works temporally, because I think that's one of the hardest issues also with improvising software. So it would be really nice to hear your views on that.
Yes, thank you. This is a very interesting question. Actually, after a few run-throughs with the musician, it was very obvious, after having trained the neural networks and everything, that the system really lacked context awareness. And I think that is a problem with AI in general. So any AI that autonomously generates or composes music, this lack of context awareness. So if the system liked a sound, it would keep playing that sound forever. And it had no sense of form. And so I had to add that to the code, so that I introduced a memory in the system so that it kept track of the different textures, how long they were, also the ratio between, for example, percussive sounds and drones. And it would have, I also built in a preference for drones so that the system, for example, will always skew towards drones rather than percussive sounds. But this was definitely one of the first disappointments with the system. So as I was composing the piece, that it really, if it liked something, it had no memory, no sense of time. It could just keep playing the same thing forever.
Well, actually, dealing with context is one of the very hard problems, open problems in artificial intelligence. So it's I'm not surprised, right? I think Artur wanted to add something. Artur, yes?
Yeah, it's just about the audience, about the audience of all this music, and who is going to get interested in this. And probably we should work on finding this audience in a like a very proactive way, through festivals or through. I mean, for me, part of the interesting participation in this project was that the composition of Ferran was going to be played in a classical like venue, or for people who were expecting like classical music. But I know there are going to be AI festivals dedicated for AI music in Barcelona very soon. So maybe we should put some effort into this and maybe play with the Turing test of music with all these audience. But I'm very interested because we have the possibility to generate a lot of music, and probably the way that this audience will absorb music or listen to music would be very different. Not so selective, but probably like a bulk interaction with a lot of music and selecting the pieces that they like because for some reason the AI was producing this kind of music.
Very good. Thanks. Before closing, let us listen and see a video listen to another piece of by Ferran Cruixent. And Ferran, yourself, you're going to tell us about.
Okay.
Introduce the piece, right? And then we'll watch and listen to the video. Ferran?
Okay. The piece where we are going to hear is Big Data. It's for orchestra. Was commissioned by the Detroit Symphony Orchestra. It was the third episode of my cyborg tetralogy, inspired by my fascination with human dependence on technology. And it's concerned not only with the obsession, but also the magic behind data clusters in the computerized civilization landscapes of the future. Big data is a term for large and complex data sets used for strong predictive analytics. Every human being who has an internet connection produces a unique digital shadow that cannot be deleted. The last musical section to be heard in this piece, that's what we are going to hear now, refers to the old popular song Daisy Bell, Bicycle for Two, programmed 1961 on an IBM 704 computer in the earliest known demonstration of computer speech synthesis. Musicians are required to use their phones and play back prepared audio. In this case, they play back a 56K modem fax dialing noises. There's an interesting story behind the Daisy Bell theme. The writer Arthur C. Clarke was present at that demonstration, and this is how he was inspired to write the novel 2001: A Space Odyssey. Just at the scene when the astronaut Dave starts to disconnect the HAL computer, the computer pronounces the famous phrase, "My mind is going, I can feel it," and then begins to sing the song Daisy Bell as a metaphor for computer childhood. This song Daisy Bell was also used by audio researchers 1974 for the first demonstration of pure decotic perception. This is why I chose this melody at the final section of my work, Big Data, as metaphor of the beginning of artificial intelligence. Thank you.
you very much. Thanks to all of you, well, thanks to the audience, thanks to the participants in this session. And just to close now for good, let me remind that the third and last session will be on May 6th and will be about musical performance and education with AI. It will be moderated by Sergio Giraldo from the Music Technology Group of the Pompeu Fabra University. Bye-bye to everyone and take care. Thank you.